You should know axon hillock versus dendrite, right? You should know axon terminals. You should know the soma, all those structures. You should know what's going on with the cell, individual cell, and how electrical physiology works of that individual cell. Okay? I'll do a little checklist up here. 1, electrophysiology. 2, you should know how neural tube develops. / neural crest. So you should know what comes from neural tube versus what comes from neural crest. And you should be able to tell me and describe for me CNS versus PNS at this point. Everyone agree? Because all postganglionic sympathetic and postganglionic parasympathetic neurons are coming from neural crest cells. They're not coming from spinal cord, they're coming from neural crest cells. Because their cell bodies are outside the spinal cord. And all the sensory neurons, that includes sensory neurons of the face and body, are all from neural crest cells. See that? So the brain and spinal cord neural tube, that's where you talk about cerebral cortex. The cortex versus the medulla, and the deep brain nuclei versus the 6 layers, and then all the white matter tracts that are running up and down, the sensory and motor tracts that are relaying, or interneurons that are relaying information of sensory from thalamus to cortex, and then motor coming from cortex straight down. There you go. So know your neural tube and neural crest, and from that, then, you should be able to tell me CNS versus PNS. You should be able to list for me all the structures that are in the CNS, all the structures that are in the PNS. You should be able to outline that, and under that, you should be able to tell me there's somatic versus autonomic, and that autonomic is parasympathetic versus sympathetic. Everybody follow? And so, this is nothing more, so this, guys, that's nothing more than a continuation. And again, we already did cranial nerve 1, because these are special senses, right? Smell, sight. What's next? Sound. Everybody ready? Can I erase this? I'll leave a little outline up top. All right. Make sure you go over that outline. Make sure you fill it in with detail. Lots of detail. All right. Maybe some water and soap. This is why it stains. All right. Get a little marker up in here. Now, let's talk about hearing. Oh, man, my markers all of them are dying. So we know we're talking about cranial nerve number 8. What's the name of cranial nerve number 8? Vestibular cochlear nerve. Everyone agree? So cranial nerve number 8 is going to be sensory. It's referred to as the vestibulo-cochlear nerve. Well, why? Well, because it's not just about the nerve. The nerve is just the wiring. It's not the apparatus. Did you guys hear me? It's not the apparatus. And so, one, the hearing apparatus, so the apparatus that feeds this nerve, because remember it's pure sensory, right? This is sensory. Neural crest, purely sensory. The apparatus is not just for hearing. It's for balance. Sorry. It's for maintaining balance through the ability of sensing vertical linear, or the vertical component of linear acceleration versus the horizontal component of linear acceleration versus angular acceleration. Bless you.
Thank you.
Okay? Separate of hearing or amplification of sound. Okay? So we have to have two apparatuses. One which will feed balance to the nerve, and another component that would amplify the sound and feed that to the nerve. Did everybody understand that? So now watch. Well, the one responsible for balance, that apparatus is called the vestibule. And the apparatus responsible for the amplification of sound is called the cochlea. Everybody see that? So now watch. Watch how simple this is. The vestibule contains several structures. So here's the vestibule. Mind you, it's sitting in the temporal bone. Yeah? So if this is my temporal bone, everybody follow? I have my vestibule, which consists of the utricle, saccule, and the semi-circular canals. All that is the vestibule, guys. Understand? So now watch. Everybody watch. Vertical component of linear acceleration. Horizontal component. So the three circular canals are designed to be one 90 to the other, one 90 degrees to the other, and the other one 45 between the two. It's amazing, isn't it? And there's fluid inside of them. And so when your head spins, the fluid moves. But it's complicated. It's fluid trapped within a tube that's trapped within fluid within another tube. So it's like a tube within a tube and then fluid in both. Got me? So when the fluid in the outer one moves, then the apparatus inside moves. And the cells that are inside the apparatus that moves sends a signal. And this is the same, guys. Whether you're talking about the structures of the vestibule and what they're sensing versus the structure of the cochlea and what it's sensing. Now watch. Here's the cochlea. And I'll draw it as a separate. That's the cochlea. So it looks like a snail shell. Now it's cool because when you take the snail shell, if you were to take it and uncoil it, everybody follow? So if I were to take this tip end and uncoil it, it's not a straight tube. It's a cone. And sure enough, what do we use cones for? To amplify sound. So the cochlea is designed as a cone that becomes spiral just because it has to be occupied within the confines of the temporal bone, which happens to be what? The strongest portion of the skull. The petrous portion of the temporal bone. Now I can tell you that this part of the bone is so hard, I tried to break my cadaver's temporal bone to get to this. And all I did was mangle the entire skull into pieces. Okay? It was impossible to get to this damn thing. And that's with a wood chisel and a hammer. You hear me, guys? Now I could tell you that a wood chisel would work really well on any other part of the human body. Okay? Because I've done that, right? Hacksaw works really good for cutting up bone, by the way. All right? Of course, then you have to worry about getting rid of the DNA evidence. So, I don't have to worry about that, right? Because I'm not killing anybody. These people died of natural causes. I'm just mutilating their body after the fact, right? And there's nothing against the law of that, right? Because they've already been deemed dead. So I have not killed anyone. Right? Let's get this clear, right? With a little disclaimer, right? I know how to torture the people after they're dead, okay? All right, so guys, this is amplification of sound, the cochlea. Got me? Versus the vestibule. Vestibule is responsible for feeding information about balance. How? Oh, well, the saccule or the utricle will do linear acceleration. I'll write it on the board. The utricle will be responsible for linear, the vertical component of linear acceleration. So the arrow going up means vertical. Vertical component of linear acceleration. And then this means horizontal component of linear acceleration. And in this, the semicircular canals, so this is utricle, this is saccule, and this is the semicircular canals. Okay?
That goes for the angular acceleration?
For angular acceleration, that's right. This goes to this guy, to angular acceleration. And so it's complicated because the ear has, again, this apparatus, it makes a mold of, imagine, you make two molds, right? But the one mold is smaller than the other, right? So that you have a tube inside a tube. You got me? So one tube inside the other tube, right? But between the two tubes, there's fluid. And then within that smaller inner tube there's fluid. So it looks like this. Outer tube, inner tube. And in between, you have fluid. So they call this the peri-lymph versus the fluid that's in here. They call that the endolymph. And so this here, that right there is referred to as the membranous labyrinth. And then this guy here, that's the bony labyrinth. So they call that the osseous labyrinth. And so again, it's like you think about it, right? I'm gonna make a model, an outer model, and then an inner model, and then between the two, I'm gonna fill it with fluid. And the outer model is nice and hard because it's in contact with bone, and then the inner model is like a membrane. It's like made of fabric, and it holds fluid in it. But then outside of that, there's fluid around it. So when the fluid around it moves, then because I'm kind of fabric-y and I'm filled with fluid, then I move too. You get me? And that translates. That translates into cells, hair cells that are in here. When the fluid moves here, the fluid in there moves. And the cells that are situated within that membranous labyrinth, associated with the endolymph, the movement of the endolymph, then the hair cells will move. And when the hair cells move, they'll release a neurotransmitter that will then get relayed through the cranial nerve 8 back to the brainstem. Sure enough, where's it going? Where's all sensory information going? To the thalamus. Straight to the thalamus. Because that's where all sensory information must go, straight to the thalamus. It's balance. Is it going to, as it's going up to the thalamus, is it going to drop off fibers to the cerebellum? What's the cerebellum for? Remember the story about boxers? Can boxers punch each other in the back of the head? No, it's unfair, right? You can't punch each other in the back of the head. Two boxers can't punch each other in the back of the head. It's not fair. A boxer who's licensed to fight in a state punches another boxer in the back of the head in a sanctioned match by the state, they'll lose their license to fight in that state, at least for a year, because it's illegal. You can't punch each other in the back of the head. Why? Because the cerebellum is responsible for balance and posture and coordinating complex motor movements. Guys, do you understand? So with these, as cranial nerves coming up, it's going to drop fibers off to the cerebellum because the cerebellum wants, yo, give me some, man. Give me some, man. My job is to help you out, bro. Hook me up. Bet, I got you. That's my job. And then don't forget, in the back of the midbrain, you have superior and inferior colliculi, right? And remember, the superior colliculi are getting input from eyes, from cranial nerve 2. Sure enough, the inferior colliculi of the midbrain are getting input from cranial nerve 8. Not the amplification, but what? The balance. For what? I gotta know, hey, where's my head in reference to the rest of my body? And am I in balance? Because if I'm not, then let me adjust my head. Remember we talked about that? Walking on the side of a hill? You want to walk like this. But sure enough, what do? You'll continue to walk on the side of the hill, as uncomfortable as it is, horizontal. To keep yourself horizontal. All right? To keep that head and your shoulders horizontal, even if you're walking on an angle. You'll try to walk as straight as you can to keep that horizontal, to maintain that horizontal. All right? Because your eyes are designed to track horizontally as well as vertically. And our brains are getting that input, all right? So that's sound and balance. Now, lastly is the tongue. So I'll draw the tongue again. Anterior. 2/3 versus posterior 1/3, and then we have to contend with taste versus touch versus taste, touch versus taste, and sure enough, on the posterior 1/3, it's all done by cranial nerve number 9, and touch is done by cranial nerve number 5. Which is general sensation of the face. That would make sense. And taste would be cranial nerve number 7. What they call the tympanic. Oh, one other thing I forgot to mention. So guys, okay, great. We got all this, right? But how is it that we translate this information? Well, there's a structure right there. It's called the oval window. And the oval window has in it the stirrup. So there's your stapes. And the stapes has the anvil. And the anvil has the hammer. And then you have your tympanic membrane. So when the tympanic membrane vibrates, the hammer hits the anvil hits the stapes pushes on the oval window, translates those waves into the perilymph, which makes the membranous labyrinth move, and the endolymph inside of it, which would then stimulate the fire. Okay? So that's why you need those 3 ossicles in the ear. And that's why you need a tympanic membrane. So when the tympanic membrane vibrates, right, then you can amplify that sound by pushing the waves through the fluid and perceiving it. Okay? This is, again, one of the weakest parts of the human body. So if you ever find yourself in a position, a compromising position, where you feel like you have no other choice, you cup your hand, you draw back as hard as you can, and you reach out for that ear and you slap through the ear. And I can guarantee you that no matter how big the person is, they will fall to the ground, they will curl up into a fetal ball, and cry their eyes out for at least 5 minutes. And at that point, you run. Okay? And you get help. Alright? Either that or you pick up the butcher's knife close by. Alright? And you do the Professor P on him, right? It is a fact. Doesn't matter how big they are. Everyone has this weakness. Because you're overriding the area that's responsible for hearing as well as for balance. And you disorient your opponent. Okay? So don't ever feel like, like there is no way out. There is always a way out. Okay? You just gotta wait till their attentions are not on you. So convince them that you're cool with whatever, and then when they're least expecting it, swap. It'll work really well, I'm telling you. It works really well. Very effective, guys. Are there any questions? Any questions? Finish those out loud.